Alright. Okay. So today we will go into a new chapter, which is chapter 3, what we call it as finite control volume analysis. And today, for this week, we will cover for part 1. Okay. But in this slide, I have already also add the part 2 section. Doesn't matter. So we focus on part 1 first. Alright. So there are 7 subchapters in this chapter. Okay, 3.1 till 3.7. So we have introduction to fluid flow. This must not. Oh, sorry, not this one. This one. Sorry. Okay. Can you see my slide?
Yes, sir.
There. Right. So we have 7 subchapters, and today we will cover 4 of them. All right. This 3.1 until 3.4. Cantik juga. So we cover 3.1, 3.2, and 3.3 and 3.4. These 3, okay, we will cover in week 8 and 9. Remember, we now in week 7, right? So these 3 will cover in week 8 and week 9, right? Okay. So introduction to fluid flow. The first subchapter is about introduction to fluid flow, right? So before this, when we cover chapter 1 and chapter 2, or mostly chapter 2, where we learn about fluid static end. Okay. If you still remember, I hope you still remember. Okay, so you find all the hydrostatic force and whatever. So the fluid is static, and that means the fluid is not flowing lah, it's not moving. Alright, but in this chapter 3, now we will dealing with a fluid flow, or we can call it a fluid dynamics end. So the fluid now is moving, okay, is flowing. So that's now the chapter is covering for that topic lah, right? So now we are in the fluid dynamic. Dynamic, you know, dynamic. What's the mean for dynamic? Is moving. So you have your velocity, you have your pressure. Okay, it's changing, and you have the value for that. Okay. So in this case, that's why we learn about this fluid flow. So there are 4 different fluid flow, which are the steady flow, uniform flow, laminar flow, and turbulent flow. Alright. So steady. What is steady flow? Okay. So if you are the guy who in the movie who like to memorize, you can do it. Okay. It's not a problem to memorize all this definition. You have to memorize and understand the real definition as a textbook, but most importantly, as I said, you need to understand what does it mean by this definition. Okay, so steady flow is the cross-sectional area and velocity of the stream may vary from cross-section, but for each cross-section they do not change with time. Okay, so I bold this sentence with red because this is the key word about a steady flow. Okay, the steady flow tu maksudnya it's constant. Dia all the velocities, all the property of that flow is the same. It's not changing with time, with respect to time. So at T1 maybe 0 hours, is that the velocity. At T2 after 5 hours, that's the velocity, the same. It's not changing. Okay, and then that's what we call steady flow. Okay, and if you found in the opposite for steady flow, which is we call it unsteady flow. So that's the velocity or the pressure or whatever is changing with respect to time. Okay, so that's steady flow lah. Okay, that's one. The second one, what we call it as a uniform flow. Okay, uniform flow. So what is uniform flow? Uniform flow, okay, the definition is the cross-sectional area and velocity of the stream of fluid are the same at each successive cross-section. Okay, so that means if you have a similar cross-sectional area of pipe, let's say this is a pipe, okay, assume lah sama, so the cross-sectional area, okay, and the velocity of the fluid flow inside in this pipe, the V, the velocity, and the area of this pipe, okay, are the same. Okay, then we can call this as a uniform flow. Alright, so that's uniform flow, and opposite of uniform flow is non-uniform flow lah. Okay, that means you have the cross-sectional area is not the same. Let's say the pipe is like this. Okay, so you have so you have kat sini bigger than for this section. When your cross-sectional area is different, your velocity will also changing. Okay, the velocity here is lower than here lah. Okay, because this is the area is smaller, that means the velocity here is larger than here. So when you have this situation, this pipe, so we can call it as a non-uniform flow, because the velocity and the area is not the same. Alright, so that uniform. And the third one, we call it as a laminar flow. Okay, laminar flow. So what is the definition of laminar flow? It also known as a streamline or viscous flow, in which the particles of the fluid move in an orderly manner. Okay, so this is the keyword, and retain the same relative positions in successive cross sections. For example, okay, if you have any oil, maybe your cooking oil ke apa ke, okay, so this is your table, your cooking table at home in your kitchen, okay, and you spill the oil, alright, so your oil on this surface kan, because of the oil is quite viscous and the viscosity is quite high, so the flow of the oil will look like very in orderly manner. The layer of the fluid, okay, is not interchangeable with the other layer. Okay, so it's all the layers moving in one position, okay, and not cross section with other layer. This is what we call it as orderly manner. So this flow we call this as laminar flow lah. Okay, so this is laminar flow. Okay, alright. And the opposite of laminar flow is a turbulent flow. Okay, this turbulent flow, okay, if I can draw in a diagram, let's say you have your surface, okay, this is your surface, table or whatever. The fluid particle, okay, for that fluid is non-steady and it move like this. It keep hitting each other. The fluid particle of the flow keep hitting each other, and it creates a turbulence. And if you go to any air terjun ke, you will find very usually turbulent flow ni related to very high high velocity of fluid, and so whenever it moves too fast, okay, and it will create a turbulence, and that's what we call as turbulent flow lah. Okay, the fluid particles not moving in orderly manner. Okay, so this what we call as turbulent flow. Alright, so this is the introduction to fluid flow. I'm not sure apa, whether this is will be asked in your test or exam. I don't have. Sekejap saya nak. Okay, I'm not sure whether you can look from your previous question or whatever, whether this is something that you need to take note. But I think as a learning process, I think everyone should take note in every subchapter, right? Alright. So that's one about introduction of the fluid flow. Okay, the next thing is in any fluid flow, okay, in any fluid flow study, there are two different approach to study that flow. Alright. So one, what we call as Eulerian, and the second one, what we call as Lagrangian. Okay. This name is based on someone else name lah, the one that they found this approach. Some guy from, I'm not sure from where, from Western country maybe. So they introduced this approach, and that's why this approach is named by them, right? Eulerian and Lagrangian. Okay, what is the difference between Lagrangian and Eulerian? All right, to understand what is the difference between this approach, I give you this example in the picture. So Lagrangian. Okay, in this first picture for this laut ni. So when they want to analyze any fluid motion or fluid flow, they track the position and velocity of each individual fluid particle. They follow all the way. Kalau dia ambil dari sini lah, to follow all the way the fluid particle, and then they measure the velocity of the fluid, whatever lah, some blah blah blah. The pressure is blah blah blah. Okay, they might be they put a probe. There's a device that you just put in the sea, and the probe will moving around, and they give you the data, and then you can track the velocity of each this fluid particle. That's Lagrangian. Alright. For Eulerian, okay, what they do is, they not doing like Lagrangian. They will define some control volume. Okay, so let's say this guy take some control volume here, alright, in this river, and they measure at that defined control volume. Okay, they measure lah the fluid velocity, whatever pressure at that control volume at a particular time. So that is Eulerian. Okay, so that's the difference between a Lagrangian and Eulerian approach in order to analyze any fluid flow lah. Alright. So why this is important? Because if you use commonly, normally in fluid flow, people will adapt this Eulerian approach to analyze, because it's much easier compared to Lagrangian. And Lagrangian, you have to track all the individual particle throughout the study lah. So it's much more cost wise, and it's much more expensive. You need more time. But for Eulerian approach, you just define your specific volume and time, and you measure at that defined value and time. So it's easier and cheap, and not take your a long time lah. Okay, so that's why in fluid flow normally people will adopt Eulerian approach to describe any fluid flow. Right. So this is just definition of it, how to understand. You can read it, okay. But that's the concept lah. That's the different Lagrangian and Eulerian, to understand the two different approach. Macam contoh dalam ni dibagi when you play snooker or pool, maybe some of you here like to play that sport. So when you hit the ball, okay, let's say you hit the cue ball to the whatever, red or blue or whatever, so you can track, right? You can track the velocity of this ball and the direction of the ball, whether it goes right or left, it depends on where you hit the ball. So this approach, because you're tracking all the way the individual balls, so this is a Lagrangian approach. Alright? Or you track the balls from starting position until the end. So that's the Lagrangian lah. Alright? But Euclidean, normally you will define a control volume. Okay, in this case you define a control volume and you measure this velocity, the fluid velocity or whatever, just in this defined control volume. So it's much more easier lah. Alright, so that's the difference between Lagrangian and Eulerian. Okay, if you have any question, just ask me, just interrupt me, I will stop. Okay, the next one is about the visualization of fluid flow. Okay, how you can visualize any fluid flow. Okay, there are a few different fluid flow. There are 4 different fluid flow, and this fluid flow is categorized by its flow pattern. Okay, so this pattern, okay, this is fluid flow. Okay, this pattern, this. So it is categorized by its flow pattern, and there are 4 basic types of line patterns. Okay, the first one, what we call as, okay, this is first one, a streamline. Okay, so what is streamline? Streamline is a curve that is everywhere tangent to the instantaneous local velocity vector. So this is the streamline. I already wrote here, label here. So this tangent to this velocity, okay, for any fluid velocity you have in x direction, in y direction. So this tangent, that's what we call as streamline. And if you have a bundle of streamline, in this case, okay, they have 1, 2, a few streamlines, and this bundle of streamline is called as a stream tube. Okay. So streamline is tangent to the velocity vector. Okay, so that's one, streamline. Number 2, the second one, what we call as path lines. Okay, so path line ni macam contoh Lagrangian tadi. So you follow all the the track, the path, the line of this individual particle. You follow that. So that line that you have followed, so that what we call as path lines. The actual path traversed by this fluid particle over some time period. Okay, maybe you set at what time? 5-10 minutes. So that path that have the fluid particle has traversed, so that you call as the path lines. Okay, so it's macam concept Lagrangian. Alright. So the third one, what we call as a straight line. Alright. So the straight lines, if you can see from this picture, the diagram, so this is, let's assume this is the aeroplane flying in the sky, right? Malaysia Airlines or whatever. So the wind or the air that have been flow through this aeroplane, at this point it will goes on top of this object N. Always because they ada resistance, and then it goes through the object, right? So this line, what we call as a straight line. So there are a point that they will start to change the line. So mula dia on straight line, and there's a point here before it hit the object, and this flow will change on top of the object. That's line, what we call as a straight lines. So this is example in maybe in a software, okay, or if you have look any software that dealing with fluid dynamics, as example as CFD, computational fluid dynamics. So you can see and you can see this straight line lah over any object kan. Or you have any lab or in a wind tunnel where you put your object and the wind flows through the object and you can see that straight lines. Okay, so that's number 3. And the last one is timelines. So as the name tells you, timeline. So it is related to time. Okay, you set any times. Okay, at this is 1 T0, and you want to analyze at any time. Okay, this 1 T1, and this is line for T2 and T3. So that timeline, okay, what have you set? So that's what we call as timelines. So it's normally useful in a situation where the uniformity of a flow is to be examined. So you want to examine the uniformity of a flow at certain times. So you use the timelines. Okay, so that's 4 different timelines. Okay, in this chapter lah. Okay, there are, I repeat again, streamline, path lines, strict lines, and also timelines. Alright. Okay, any question before we go? Okay. So the next thing is, in chapter 3, as I mentioned before, we are dealing with a fluid that is moving and what we call it as fluid dynamics. Dynamics. Okay, and there are few parameters that we are interested with. Okay, such as the velocity, okay, the pressure, the elevation of the fluid flow. So that's some of the parameters. And when we're dealing with this fluid dynamics, okay, it will depend on 3 different laws. 3 different physical laws. Okay, as you know, in physics there are a lot of laws. Okay, hukum-hukum. Kalau dulu saya belajar hukum-hukum lah. Ada ni in Malay. Okay, so in this chapter, fluid dynamics, there are 3 different physical laws. So number 1, what we call as law of conservation of mass. Okay, so all these notes mentioned in the note part 1. If you go to your classroom, if you refer to notes 1, and all these things I write here, it's all in that note lah. So don't worry if my handwriting is not really clear. You can always refer to the notes. So number 1, what we call as law of conservation of mass. Okay, and number 2, what we call as first law of thermodynamics. Okay, and the third one is what we call as second Newton's law. Newton's second law. Okay, I think we have learned it before in school, isn't it? The F equal to ma. Dah belajar dulu kan sekolah?
Ada sih.
Ada. Okay, this is what we have learned, and I think you are familiar with this law. Okay, so these 3 laws, what they are doing is, okay, as the name tells you, for example, the number 1, law of conservation of mass, that means, okay, there are a few equations. There must be a few equations, and also what they balance. Okay, for example, for number 1, law of conservation of mass, that means the mass is balanced. Okay, because you conserve the mass. So that mass is balanced. And the second one, the first law of thermodynamics, this is regarding the energy. Okay, so you conserve your energy, balance your energy. And the last one, the Newton's second law, this is about balancing the momentum. Okay, so there will be equation for different equation for these laws. Okay, and the first one, the law of conservation of mass, what we learn today, and what we call as continuity equation. So this is, we will look after this. Okay, and the second one, the first law of thermodynamics. Okay, this is the energy equation. Okay, we will look it in next in different week. Okay, in week 8. And the last one, the Newton's second law, this is about the momentum equation lah. Okay, momentum equation. So there will be three different equation for different laws, and these laws will balance a different thing. One will conserve or balance the mass, and the second one will balance the energy, and the third one will balance the momentum. Okay, so what does it mean by balance? Okay, when I said balance, alright, so if you have any fluid flow in any pipe, okay, let's say this pipe, alright, okay, at point 1, and there's another point 2. So what is meant by balance? That means the mass at point 1 will be equal to the mass at point 2, right? And the energy at point 1 will equal to energy at point 2, and the momentum at point 1 will be equal to momentum at point 2. So this is meant by balance. So you can equate that, and then you can calculate lah whatever property that you want to calculate. Okay, so that's three different physical laws that we will learn in chapter 3. And for today, we will look at the first one, this one, where it's about the continuity equation. Okay, alright. So continuity equation, or I will call it CE for the rest of the lecture. What is means by this continuity equation? Alright, as it tells you, is a law of conservation of mass, and it's balance the mass. Alright, so there are important parameter for CE, what we call as flow rate. Okay, and I think everyone of us understand that flow rate. Okay, flow rate is anything lah per time kan. You want to calculate anything, volume ke, in this CE, in this continuity equation, what we like to find is to measure is the volume, mass, and weight. So all these three, we like to find the rate. Okay, so rate is always related to time lah. Okay, you divide by time, and this time always in seconds. The standard unit for time is second. So you need to ensure that if you do any calculation in flow rate or rate, you need to use time in second, not in hour, not in minutes, unless it's stated otherwise. You want to find in minutes. Example, the RPM, evolution per minute. So that's fine. That's also flow rate. Okay, but in minutes. But normally in this chapter, we will dealing with per second. So flow rate is quantity of fluid flowing in the system per unit time. Per unit time. Okay, in second. Right. So there are three types of flow rate: volume flow rate, or the symbol is Q; mass flow rate. Okay, the symbol is M dot. Right. And the last one is weight flow rate. okay, W dot. You might find your friend in other class, okay, their lecturer teach them the volume flow rate is V dot, okay. So it's just the same thing, just a different denotion, okay. Maybe their lecturer like to use V dot to make it consistent with mass dot and with W dot and M dot. But I refer to I'm using Q. Okay, because there are a lot of different textbook. One is Q and one is V dot, so it's just the same thing. Okay, but I like to use Q because in the future, in any calculation, you will find another V, which is the velocity, right? So I don't want to confuse with V for volume and V for velocity. So that's why I'm using Q for volume flow rate. All right. So there are three. So the first one is volume flow rate. As the name tells you, it's a volume. So this must be in meter cube. Okay, you know volume. And rate per time, so per second. So that's why the unit for volume flow rate is meter cube per second. So remember, the unit is very, very important. Don't take it for granted. If you do any calculation in any question, don't forget about units. Okay, make sure you use the right units in your calculation, otherwise your answer might be wrong. Alright, so the unit for volume flow rate, volume meter cube, and flow rate is per second. That's why you have meter cube per second. And how you find the volume flow rate is A times V. So A is area. Okay, the area of the cross sectional that where the fluid is flowing. So this is in meter square, sorry. And the V is the velocity of the fluid flowing. Okay, and this is meter per second. Okay, and if you multiply area and velocity, that's why you get the unit for volume flow rate is meter cube per second. Alright, it's easy as that. Volume flow rate, area times the velocity. Okay, so that's one. The secondly, the flow rate that we are dealing with in continuity equation is the mass flow rate. Okay, so the symbol is m dot. Alright, so what is mass flow rate? Okay, mass of fluid flowing in a system per unit time lah. Sama juga lah macam volume flow rate. Tadi volume per unit time, mass per unit time lah. Alright, and how you find your mass per unit time? It is this equation. So m dot is equal to rho, the density of the fluid. Okay, mentioned here. A, the area, the cross-sectional area of the pipe or duct. Okay, whatever. So the area times the velocity of the fluid flow. Okay. If you realize the only different thing from your volume to mass is just you multiply with your density. So density times area times velocity. The density times area times velocity will give you your mass flow rate. Okay, as the name tells you, mass is in kg. Okay, flow rate is in per second. So that's why the mass flow rate unit is kilogram per second. Okay, so rho times A times V, or you can find, if the question already gave you the volume flow rate, remember this A times V is also equal to Q N. Okay, that's why you can also write it as rho times Q. Rho times volume flow rate will give you your mass flow rate. Okay, so that's mass flow rate. Okay, the mass of fluid flowing over time. So that's two. Number two. The number three, the last one, is weight flow rate. Okay, weight flow rate, W dot. Okay, W dot. Okay, the weight of the fluid flowing sama juga nama dia flow rate kan, per unit time jugalah. Alright, so weight, as you know, the unit of weight is Newton kan. Okay, remember weight equal to mg kan. Kalau you in physics we learn that. So in Newton, weight in Newton and flow rate per second. So that why you find the unit for weight flow rate is Newton per second. And what is the difference between mass flow rate and weight flow rate? If you can see from the formula, the weight flow rate is equal to the specific weight of the fluid times Q. Q, remember the volume flow rate, okay? And this specific weight can also be changed in rho g, rho g, remember rho g, rho specific weight is equal to rho g kan. You have learned this one in chapter 1, Is it chapter 1 or chapter 2? I'm not sure. Chapter 1, I think chapter 1. Okay, your specific weight is equal to rho g. So you can, if they give you specific weight, you can use specific weight lah. But if they don't give you the specific weight, maybe they just give you the rho of the fluid, then you might use this term lah, rho g times q. And or if they didn't give the q, but they give the area and velocity, so you can change the q to AV, the area times velocity. So the equation can be in rho g times A times V, to get the weight flow rate. It's just a change of this equation. It doesn't it's not too difficult. It's just a change of the definition the equation. Okay, the rho the weight can be changed in rho g, so that's why they put rho g q, and q can be changed in AV. Okay, that's why it's rho g AV. Okay, so that's how you find your weight flow rate. Okay, the weight of fluid over time. Okay, so normally in continuity equation problem, so they will ask you to find all this flow rate lah. Okay, the volume flow rate, the mass flow rate, and also weight flow rate. Okay, so you will find more example in tutorial or in past year exam. Is a very common question lah. Okay, so this continuity equation, as we mentioned before, is based on the conservation of mass. Okay, if we have seen, I've mentioned before, it is the conservation of mass. So whatever mass is flowing inside at the inlet is conserved at the outlet. Okay, it's the same. Okay, whether it's a mass or weight, the volume, weight or mass. So all this been conserved in this in the pipe lah, right? So the conservation of mass states that under steady flow condition, the quantity of fluid entering, okay, let's say this one entering here, okay, and leaving an open system must be equal over a period of time. Okay, this is the keyword. Okay, must be equal. Whatever the velocity here must be equal to the velocity at this outlet. Okay, whatever area here must be equal to area. Equal to not means that the same value. Okay, don't get confused with equal to. Maksudnya kalau area sini 4 meter square, not means that the area here is also 4 meter square, and it is 2, dia kecil kan, so it's smaller, but because we use a conservation of mass, so whatever enter will leave the same. Okay, apa yang masuk mesti keluar benda yang sama juga. Okay, so that's why we have all this equation. Okay, the volume flow rate, mass flow rate, and also the weight flow rate. Okay, so in terms of mass flow rate, okay, so whatever, so this is not, benda ni semua tak sama. A1, V1, V2 ni tak sama. Okay, it's different. The area at point 1 is different with the area at point 2. The velocity at point 1 is different with velocity at point 2. But the multiplication of that, okay, V times A is volume. So that volume entering inlet must be equal to volume exit the outlet. Okay, that's what it means by equal. Okay, so that's how you can use the equation to find lah whatever velocity in this pipe or in this duct. Alright, so that's continuity equation. Okay, so for any fluid flowing in this pipe, okay, the law we assume that the fluid is incompressible. Alright, that means the rho of the fluid, okay, the rho of the fluid is not changing. Okay, not changing, it is the same. So that is meant by incompressible. Maksudnya fluid tu kita boleh nak compress dia, tak boleh nak tekan dia. So if we have incompressible fluid, that means the rho of that fluid is constant. So the rho at 1 is also the same as rho at 2. So it's a compressible fluid. Okay, but if you have a fluid that can be compressed, okay, such as a gas, that means the rho is changing. Okay, the rho at point 1 is not the same the rho at point 2. Okay, that was it mentioned in this note. However, for gas, the fluid flow are compressible. That means the rho is not constant, it's not the same. So you cannot cancel out the rho term in this equation. Because kat sini kalau fluid, kalau liquid, and if they said is compressible and the rho is constant, so that means the rho here can be cancelled out lah. That's why this is cancelled out, because it's the same value. But for gas, which is for gas or whatever fluid that are compressible, so your rho cannot be cancelled out because it is not the same. Okay, that's why you need to use that value in your equation. Okay. Alright, so there is one task here. Try writing the continuity equation for the pipe system below. Okay, how we can do this? Give me example like this one for Q. For Q, you know Q is equal to a Vn. Okay, so how you can write this continuity equation for this pipe? There are pipe coming, and then they are divided by two branch. Can anyone answer or want to try to answer? Ada? Nak cuba? So in term of A1 V1, A2 V2, A3 V3, how you equate this term? Hello, ada ke ni? Is anyone here? Tak ada.
Ada, sir.
Ada, okay. So how you can equate this? I already give you an example for this, for this one, and the answer is like this kan? A1 V1 equal to A2 V2. But how about this one? They have a branch, ada dua dekat outlet dia.
Dia equal je semua, sir.
Equal semua. Maksudnya A1 V1 equal to A2 V2 equal to A3 V3.
Ya kot.
Like this. Okay, a good try. Doesn't matter. We are learning. We are not judging anyone. Anyone want to try? Ataupun
A1
Saya tambah, sir.
A2 plus A3 V3
equal to A2 V2
plus A3 V3
plus A3 V3. So which one you answer? You cannot give two answer in question. You need to choose one. Anyone want to help? Which one do you think the correct one? Okay. So the answer is this one yang summation Okay, good try, and you give a good answer, a correct answer. So whatever inlet, whatever goes to the inlet must be equal to whatever goes to outlet end. because you have two outlets, that's that means you need to sum the two outlets lah, kan? Because you have one go to here and one goes to here, kan? So this summation of two outlets, 2 and 3, must equal to the one that inlet lah, kan? Logically speaking, apa yang kan dia kata whatever goes inside is the same equal to whatever goes outside, from this principle, kan? Kata the quantity of fluid entering and leaving an open system must be equal. Okay, so dia enter kat sini and dia pecah dua. So that pecah dua need to add lah to have the the total number whenever it enters the fluid. So if you have another one, let's say you have another branch here, so that's mean just add another term lah, so A4 V4, okay, because it is summation of outlet and inlet, so outlet kat sini, inlet, okay. I give you another example. If you have like this, so this is the outlet, okay. Ada 3 outlet, 2 inlet. How you can write that? Let's say this 1, 2, 3, 4, 5. Macam mana? Ada? Cuba. Ni inlet, ni outlet. In term of A1, V1, A2, V2, A3, V3, A4, V4 and A5, V5. How you can write it?
One plus 2
1 plus 2, okay, good.
equals to
Equals to
3 plus 4 plus 5.
okay. Dah macam ni lah, betul lah. That's correct. Well done. One ni maksudnya A1 V1 lah, A1 V1 plus A2 V2 is equal to A3 V3, A4 V4 and V5 V5, So it's apa yang masuk mesti sama dengan apa yang keluar. That's the concept lah. Okay. So if you have in the question that you have a lot of pipes for your inlet and your outlet, don't confuse. It's just the same thing. Whatever comes in is the same whatever it comes out. Okay. So that's correct lah. Okay. The volume flow rate at 1 plus the volume flow rate at 2 must be equal to the volume flow rate at 3 plus the volume flow rate at 4 plus the volume flow rate at 5. Alright. So that's continuity equation. So let's see some example. Okay. So this one, okay, senang lah sebab dia hanyalah ada satu branch je, ada satu yang masuk, satu yang keluar. It's not complex like I draw it before. So the figure below show that oil, so they give you the density of the fluid, which is oil, equal to 857, flowing from section 1 at velocity 1. Okay, they give you velocity 1, which is 2.5. So here is 2.5 meter per second. To section 2 at velocity V2. So they didn't give you the velocity 2. They want you to find it. The diameter at section 1 D1 and section 2 D2, and they give you the number is here 30 centimeter and here is 15 centimeter. Right. And they ask you to calculate the V at section 2. Okay, V2, and that's the first one. And the second one, they ask you to find the volume flow rate of oil. And the third one, this is Q, kalau you remember, volume flow rate is Q, nak cari Q. So this one nak cari V2 and the mass flow rate, which is the mass dot. Okay. So simple like as we have learned the equation for that, for all of this problem. Okay. whatever enters the inlet will goes to outlet, right? So here they write all the required equation as we have learned in many chapter before. You have few steps that you can do. Okay, first dah ada diagram, so you don't need to draw the diagram. Okay, so this is the diagram and you can label the velocity, whatever information that they give you. Okay, the row as well, the row they give you the row 857. Okay, and they give you everything, so you label your diagram so that you are clear what's the problem. Okay, and then you can write your required equation. So you have your mass flow rate. So they want you to find your mass flow rate. So mass flow rate at 1 must be equal to mass flow rate at 2. Alright, and this can be write as rho 1 times area 1 times the v velocity 1 is equal to the rho 2, the area 2 and the velocity at 2. Since this is incompressible flow, we assume that because it doesn't mention anything about compressible, so the rho at P1 is the same at P2. So you can cancel out this rho 1 and rho 2, and this will give us only A1 V1 is equal to A2 V2, and this is also the same. If you remember, this is a Qn. You know Q is equal to area times Vn. We have learned that before. Okay, the Q is area times V. Okay, so the volume flow rate. Alright, the volume flow rate have a term of velocity, and they ask you to find your velocity. Kat sini so find V2. Okay, so you can use A1 times V1 is equal to area 2 A2 times V2, so that will give you your V2. Okay, that's one equation that you can use for answer to answer the velocity. The volume flow rate ni saya tukar ni Q sorry, Q, so not V, but I'm referring to other lecturer slide. It is a Q2 so don't get confused. Right, so Q to find the volume flow rate of oil, so you can use either one, whether at point 1, so you can use A1 times V1, or you can use at point 2 and you use A2 and V2, and this should be equal It doesn't it shouldn't be different value. It should be Q1 must be equal to Q2. Okay, so doesn't matter you use at point 1 or point 2, we will give you the correct answer. And the last one, the mass flow rate, and you know the equation to find the mass flow rate is just times the volume flow rate with rho. So you have rho times A1 times V1, or rho for section 2 section here, rho 2 A2 times V2, or this one also can be used as Q1 A1 V1 sama dengan Q1. So you have already find your Q1, you can just replace that in Q1. Okay, so this is the solution. Alright, to find area, remember the area for a cylinder pi r squared. Okay, they gave you the diameter here 30 cm and 15 cm, so you need to change it in radius. So this is 15 cm radius. Okay, and you need to change it in meter, so this is 0.15 meter. And for this one, so this is 15 divided by 2 is 7.5, so your radius is 0.075 meter. Okay, so you can find your area, so just 5 pi r squared. You find your area 1, okay, and you find your area 2. So you just use your equation for volume flow rate, you can find your velocity 2 That's what they ask you to find, and this should give you the answer for volume. The velocity at 2 is 9.986 meter per second. Alright, again, don't remember your unit. If they ask you, okay, in this example, they have already mentioned the velocity and they give you the unit, so you need to give your answer in whatever unit they ask you to answer. Okay, so that's settled for number 1. And they ask you to find volume flow rate for oil. Okay, you already have your V2. Even though you not solve this question, you always can you already can answer the question for volume flow rate, because you already have your A1 here. Okay, and you also have your V1, so you can use that to answer the question for volume flow rate. And the A1, you have your A1 here, pi r squared times the velocity at 1, 2.5, and it should give you the answer 0.177, and this should equal to as well, if you use A2 times V2, if you multiply 0.0177 and 9.986, it should give the same as ni lah, 0.177. Alright, okay, so that's volume flow rate. Alright, so last they ask you to find mass flow rate, which is the m dot, and you know the mass flow rate is just multiplication of rho with q. Okay, you already find your q, 0.177, or you can use as well times a and v, whatever you choose, which one you find easier. So you just multiply by the rho. Okay, the rho of the fluid 857, they provide you the rho of the fluid of the oil is 857, so you just times q, okay, times 0.177, it should give you this answer. Or you want to times the area of 1 and the velocity at 1, it should give you the same answer juga lah. Or you want to use at point 2, maybe you want to find the m dot 2, it should also give the same answer like this. Okay, so that's continuity equation. How do you find it? Is it easy or difficult? Any thoughts? Senang tak?
So far so good, sir.
So far so good.
Boleh sir.
So if anyone want to ask, just ask. Okay, so second exercise, okay, this we go to next. Okay, so second exercise, so this is ada branch, right? So water pipe AB branch into two pipes C and D, as shown in figure below. So the pipe has a diameter of 45 cm at A, so they label to you, and 30 cm at B, 20 cm at C, and 15 cm at D. If the velocity at A, okay, here VA, okay, we call it VA, is 2 meter per second, okay, meter per second. Calculate the volume flow rate at A. So they ask you to find QA. Okay, berapa? So that's one. And they ask you to find the velocity at D here. So they want to find the velocity at D, VD. If the velocity at C, so they give you the VC is equal to 4 meter per second. Okay. Okay, number one, how you can solve the volume flow rate? Q. So if Q equal to
AV.
AV, kan? AV, and they ask you to volume flow rate at A. So remember, don't forget to label your equation so that you don't confuse. So they ask you to find volume flow rate at A. So you need to use every property at section A. So the area at A and the velocity at A. So your velocity, the area at point A, you have the area because they provide you the diameter 45 centimeter, and you can just replace it to find pi r square times V. Okay, so the area pi times 45 divided by 2 sama dengan apa? 22.5 kan? Okay, that means 0.225 square times V. The V is given to you, right? Is 2. You mentioned here. The velocity at A is 2. So times 2. And this should give you the answer for question number 1. Apa value dia? Pi times 0.225 squared times 2. Is it the same like here? 0.318? Let me allow some people. Betul?
Sama saya.
Sama Sekejap Okay. So the answer is correct. Okay, I didn't check it, but you check it. So 0.318. Don't forget the unit, meter cube per second. Okay. So that's one, the volume flow rate, and they ask you to find the velocity at point D. Okay, how you can find for question 2? What you want to use for what equation you want to use to find VD? Anyone?
A1 A1 pula. AA VA
Okay.
equal
Equal
to AC VC
ACVC
plus
plus apa?
VD AD VD AD
ADVD
AD VD.
Okay, that's good. So why? Because the volume flow rate at A sama dengan volume flow rate at B, and this A or B, you can choose whether at A or B, this must be equal to the summation of C and D. Right? So siapa yang jawab ni?
Ideal.
So Ideal choose A1 AAVA, or might as well some of you want to choose ABVB. This also correct. Okay, ACVC plus ADVD. Okay, because apa yang masuk keluar kan. So QA and QB is the same, and this value is equal to the summation of QC and QD. Okay, summation of QD plus QC plus QD will equal to QB and it will equal to QA. Alright, so you just choose either one lah. Whatever you find is easier, you choose one. So you have So I did choose this one. I think that's the best option because you have the A, the area, and you have the V. Kan? If you choose the ABVB, you don't have the VB. Kan? Then you need another job lah. You need to find the VB first from the QA ni. Then you can use this equation. Okay? So I did choose a very short way, and that's the best way. We just use AA VA equal to AC VC plus AD VD. So the AVA you already find here, 0.38318. So this is equal to pi A for C is 0.1 squared times 4, okay, plus the area at D is pi times 0.075. Ya kot, itulah squared times VD, the one that you want to find. And so your VD should equal to, is this answer correct? 10.87. Can someone calculate this?
Saya dapat sama dengan jawapan.
Sama So that means the answer is correct. So 10.87. And don't forget the unit, meter per second. Okay, so velocity. So that's how you solve the question. This, I think, is quite easy. Maybe not too easy. Okay, but I think it's quite doable lah. It's doable. Just using all the continuity equation, and you should can answer the question. Right, any question before we proceed to another example? Okay, we have more. Alright. Ada lagi soalan? Ada soalan? Okay, like I said, don't afraid to ask. Just ask. Okay, next example. In figure 6.1, the inside diameter of the pipe at section 1 kat sini, okay, and 2 kat sini, 2 kat sini, V2 50 mm, sini 50 mm, and sini 100 mm. Okay. Water is flowing with an average velocity of 8 meter per second at section 1. So V1 here is 8 meter per second. Okay. Calculate the following. So they ask you to find V2 berapa, and they ask you to find volume flow rate Q. They ask you to find weight flow rate W dot, and they ask you to find mass flow rate M dot. Okay, someone, how you can find for A first, the velocity at section 2. What we can use the equation. Velocity at point 2. Ada nak cuba? Ada? Tak ada? Sama je. Tadi juga A1V1. Ha? Macam mana?
A1V1 equals to A2V2.
Yes, betul. Sama je. A1V1 is equal to A2V2. Okay. And your A1 is pi. R dia berapa? Berapa nilai radius at point 1? Berapa nilai radius?
0.025.
0.025.
25.
So they give you in millimeter. Okay, don't forget to change back in meter. Okay, so then you need to divide by 1000, and radius is just divide by 2. Okay, 0.025, that's good. Squared. So pi r squared times V1 is equal, they give you the V1 is 8. So this is equal to A2 pi r squared 100 50, so 0.05. Okay, 0.05 squared times V2, that one, the one that you want to find. So your V2 should equal to berapa nilai V2? 2. Okay, 2. So 2 meter per second. So that's settle. If you realize, as your area is larger, then your velocity will drop, will decrease. Kat sini 8 kan, masuk 8. Sebab the area is smaller, your velocity will be higher. When it goes to the outlet, because the area is larger, your velocity at point 2 must be lower than the velocity at point 1. If you calculate and it's higher, then it should the answer should be wrong. You know, if area is larger, then the velocity must be dropped. Okay. And the next one, the volume flow rate, the Q. How to find the Q? What we use? Anyone? Volume flow rate, Q equal to
AV.
AV,
Sir.
So you just use anyone, A1 V1 or A2 V2, just simple as that. Okay, you have, let's say at 1, okay, pi times 0.025 squared times 8, and this should give you the answer. Apa jawapan dia? Anyone use the calculator? Berapa ni?
0.016.
0.016. Okay, 16. Sorry, 16. Apa unit? Volume flow rate?
M cube per second.
Meter cube per second. Okay, so 0.016. So settle for number 2, P. So now C, the weight flow rate. So I move here. Okay, there's no space there. Weight flow rate. How you can find your weight flow rate? What you do? What's the equation for weight flow rate?
Rho GQ.
Rho
G
G
Q.
Q. Alright. So the rho, so they give you here is water. You can use water 1000 times G times 9.81 times Q. So you already find your Q. What's your Q here? 0.016. And this should give you the answer lah. So what's the answer? The value for weight flow rate?
156.96.
56.96. Value?
1.96.
Apa tak dengar?
Betul sir, betul sir.
Betul, okay. The unit? Weight flow rate. Remember what's the unit for weight flow rate?
Newton over
Newton
Second.
per second.
second.
Second, yeah.
Okay. Lastly, so you have done C. Lastly, the mass flow rate, which is m dot. So what's the equation for m dot?
Rho AV.
Rho AV, or what else? The simplest one?
Rho Q.
Huh?
Rho Q.
Rho Q. But you already find your Q, right? So you can use your Q. So this is rho 1000 times Q 0.016, and this should give you 1, 2, 3, 16, 16, betul?
Yes sir.
16, the unit?
kg per second.
Kg per second. So that is all about continuity equation. Kan? I think they give you also the how to do it. So this is here. Okay, is it the same? So A is V2 is equal to 2. So we get A2, okay, correct. Q 0.01557 So maybe ada apa sedikit kelainan, maybe because of this apa number of titik perpuluhan so decimal place, so just the same lah, so that's correct. Okay, so dia jangan rasa salah pula betul lah kan, dia hanyalah nombor perpuluhan lah kot ambil nombor perpuluhan lain so this is 0.0157. Okay, the next one you will find this is 0.15 sorry 0.151, and what we get 156.96 is Newton per second, and they provide in kilonewton they give kilonewton, so it's just the same lah. Okay, so because the Q they use 0.157, we use 0.016, so that's why it's different, doesn't matter. And the last one, D, the mass flow rate. So they get 15.36 and we get 16. Okay. Oh, I know why it is different. Can you notice why it's different? Can you notice why the value is different? Someone?
Newton. Mass dengan weight.
No, they use a different value for density, and they use different value I think in this question it's not complete. Maybe they give you a specific weight kot. But suddenly here in this example they said from table 6.1 the specific weight of water is 9.59. Okay, so that's why it's different. Okay, so in this, when we did the calculation, kita just assume the row of the water is 1000. So that's why our value is different, but we are still correct. Okay, maybe the question is not complete, and the jalan kerja ni macam banyak lain pula. Ada at 70 degree, the survey is 4.95, maybe not complete. So don't worry, you did the right work. Okay, you just use, maybe in this one they should give you any additional information like the specific weight 9.59 here. Okay, okay, boleh tak confuse kan why we get different? Alright, understand? Boleh kan?
Boleh, sir.
Sir nak tanya, untuk mass flow rate tu kan
Yes.
kita pakai apa?
Ni.
kg per second kan?
Okay.
Boleh tak kita ambil daripada nilai weight flow rate tu, kita darab je dengan nilai gravity?
Weight flow rate.
Kita bagi dengan nilai gravity sebab nak dapatkan kilo kan? Boleh tak?
Boleh. Cuba buat kira, dapat sama tak?
Dapat sama?
Then should give you the same answer lah. You can play, you can go around to just divide by G, and you should give the same lah, because from the equation pun this is rho GQ and this is rho Q, so you just divide by G kan. Betul lah tu.
Okay, thank you sir.
That's good. Alright. Okay, so now it's 1:45. So as a recap, I think this is the last slide. So as a recap, in continuity equation, okay, you have one volume flow rate, okay, Q, and secondly you have a mass flow rate, m dot, and lastly you have a weight flow rate, and this volume flow rate is equal to your area times velocity, and the unit should be in meter cube per second. Alright, and your mass flow rate is equal to your rho times Q, okay, or rho times A times V, sama juga rho Q ni. So this should be in kilogram per second. Okay, and lastly, finally, your weight flow rate, okay, as you said, you can just multiply by G. Okay, it just multiplication to G, so rho GQ or rho GAV, okay, or you can also, if they give you specific weight, also can give in specific weight gamma times Q, because rho G ni sama dengan specific weight kan, sama okay, and this is in Newton per second. Ada tiga lah, volume flow rate, right here, mass flow rate, and also weight flow rate. Okay, any question before we end our class?
Sir, saya tengok notes part 1 tu dia dalam bentuk PDF sir.
PDF, betul.
Dia macam lain dengan slide ni je.
Apa yang lain?
Macam Macam dia lain dengan yang slide sekarang ni.
Slide ni memang lain tak apa. Slide ni apa, I just refer the notes and make it a slide. What do you mean by lain tu? Apa yang different?
Slide yang present sekarang ni tak sama dengan slide.
Bukan dia bukan yang sama, maksudnya sama. The notes is the note, the nota tu nota lah. So the slide here is the slide. It's not the one apa, bukannya I just translate this slide into PDF. Not that what I mean. But the content should be the same lah, the content. Is it? Benda dalam tu sama je kan disebut kan? Volume flow rate, mass flow rate semua ada tak dalam tu?
Yang saya tunjuk ni lebih mudah faham.
Lah untuk pengajaran saya suka macam ni lah. So the note is just for you to read, okay? So that's why macam textbook lah, textbook. So you can read from the textbook, from the notes, or you can just refer my slide lah. It's just the same thing, it's just the same content. I think the note also use the same denotation. They use the volume flow rate as a Q. Betul ke? Dia guna Q, the volume flow rate. Tadi siapa dia cakap dia?
Betul saya betul.
Sama Is there any confusing ni kan? Ada confusion kan?
Cuma slide saya ni lagi mudah faham lah.
I will post the slide in the classroom. Don't worry. And I will give you this recording video. You can access from my YouTube channel. And you can refer the notes as well lah. So you have a lot of materials you can refer. But it is a lot just the same thing lah. Okay. Alright. Any question? Anything else you want to ask? Tak ada. So that's for today. We learn about continuity equation. Okay. And tomorrow we have one more class kan. So I will give more example lah on continuity equation. So we will not go into the new subchapter, the Bernoulli's equation yet. This one will be covered in next week after you come back from your mid semester break. So tomorrow we will do more question on continuity equation. Tutorial. I will provide the tutorial and we can do it in the class together. Okay. Alright. That's all for today. Thank you for your attendance and your involvement. We will meet again tomorrow. So assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir. Thank you, sir.
Thank you, sir.
Don't forget to fill up the attendance form. Sorry.
Okay, sir.
Okay, sir.